it would look like water, doesn't it? Salt water looks like water, doesn't it? So anyway, when you have an aqueous solution of this stuff, we're going to make one of those, and we're going to mix it with an aqueous solution of another chemical there. There are two products in this reaction. One is insoluble. All right, Isabel, what does insoluble mean? Real loud. We've used that word several times. What does it mean if it's insoluble? Have you heard that word? All right. What do you think, Julie? Insoluble. It does not dissolve. So when you put these two things together that look like water, you're going to get a thing that does not dissolve, and it's called a precipitate. Remember talking about that? It's a precipitate, meaning it's a double replacement reaction. You're going to get a solid like that. And that's an insoluble solid, and then that means it will precipitate out. It's called a precipitate. The other one will be a soluble salt, and will we ever see that? If you have a product of a reaction and it's in water and it's soluble, will you ever see it? We'll never see it. One of these things we'll see. It'll be very clear. You won't miss it. And one of them you'll never see. All right, here we go. The insoluble solid will separate from the liquid dried, and its mass will be determined. The value of the experimental mass will be compared to theoretical mass. And what are you going to calculate there? What can you calculate when you have experimental mass and theoretical mass? Remember that? Experimental over theoretical times 100, what was that? Percent yield. So we're going to do a percent yield. I'm going to challenge you to see when you can get the highest percent yield in this class. If you get above 80% yield, you're doing a great job. If you're above 90, you did a really good job. If you get above 95, it means you were really, really careful. It's going to be hard to get 100% yield. All right? Okay, so what we're going to do is I'm going to go through this real quickly, and then you're going to get with your groups, and you're going to say, let's pretend that Daniel and I are partners, and we're sitting together, and we're going to make a little, I'm going to have you guys turn in a piece of paper, and it has everybody's names on it, okay? And you say, tomorrow, when I get here tomorrow, here's what's going to happen. It says here, using a balance, measure out exactly, wait a minute, chemicals, wait, you can't deal with chemicals unless you have what on? What do you have to have on? Goggles, right? So, we're going to say, Daniel says, hey, Mr. Feeney, you go get 2 goggles for both of us. Oh, what happened? Okay. No. Okay. Anyway, so when you do this little plan, you'll say, Daniel say, Mr. Feeney gets 1 pair of goggles for the both of us. And now what you're going to do is, Daniel said, Daniel goes and measures out exactly 3.31 grams of lead-2 nitrate. So what I'm going to do is I'm going to have, remember the electronic balances? We have electronic balances that weigh things. And so plan number 2 is Daniel will go weigh out, and you never put chemicals directly on a balance. Isn't that right? So what he's going to do is, it's got to be in a beaker anyway. So the more we read here, it says here, he's going to eventually put it in a 250 milliliter beaker. So he's going to get a 250 milliliter beaker, and he goes over to the balance. How do you, when you're using a balance, I'm seeing it from the top here. Here's your numbers. What if I put a beaker on there, and I don't want to weigh the beaker? I only want to weigh what's in the beaker. How do we do that? Have you done that before? What is it? It does. So we have a little button. I have 2 balances. One of the balances, you press the on button again, and it will subtract. It will subtract the weight of the beaker. That's called a tare mass. So if you ever get into the chemistry field, the tare mass or tare weight is the weight of the container. Okay, so that's called a tare mass. Now, so what will happen is now the balance reads 0, even though something's sitting on it, it reads 0. And then I'm going to use, do you remember scrupulous? Remember how you had learned those? Remember how you scrupulous? Okay, so you're gonna have a bottle of this chemical. You're gonna say, I'm gonna double check. What chemical am I supposed to do first? Lead-2 nitrate. He's gonna make sure that that bottle says lead-2 nitrate. Turns the bottle inside, scrupula. Okay? Now, here's his beaker on the balance. He puts some in there, and it gets to be about 2.5. So he wants to slow down a little bit, right? What you can do is take your finger and just tap it. You can tap it like, see that? And one crystal comes out, 2, 3, 4. And then your goal is to try to get exactly 3.31 grams. Now I'm going to have 2 balances, okay? So he's going to be at 1 balance, and then what should the other person do? What's the next person going to do? Okay, place the chemical in a clean beaker, and then they're going to add 50 milliliters of water. Now, because I know a little bit more about this lab than you do, I do not want to use tap water. I'm afraid tap water is going to cause a little problem, so we're going to use, would you make a little note here? When it says water, put distilled water. Now I have back there, do you see that big jug? That big jug, I went to the store, and I have another one, but that's distilled water. So we're going to use distilled water. Now, this does not have to, this has to be exact. This has to be exact. This does not have to be exact. So on the beaker, there's even some lines on the beaker, and it says like 20, 40, 60 milliliters. This does not have to be exact. This is about, okay? Okay, now we got the water in there with the chemical, and so Daniel's done what he's supposed to do. But what's the other person going to do? The other person says they're going to measure out what? How much are they going to measure out? 3.50 grams of another chemical. Everybody see that? I had one group, the honors kids already did this, and I came by and they were mixing them together, and I know what's supposed to happen, and it didn't happen. I said, well, who did the chemicals? He said, I did both of them. So the same person did both chemicals. And then I went and said, well, show me where you got the bottle from. And what he did is he made 2 of the same solute. That's why he didn't get a reaction. He made one like that, and he made another one like that. He picked up the same bottle. Okay, so when he mixed them, he didn't get a chemical reaction. So one person is going to make that one, and one person is going to make that one. You get that? Now you're also going to put in there, this is going to be in a smaller beaker. This is like a 100 milliliter beaker. And you're also going to add 50 milliliters of water. So when you get to your groups together, you're going to say, number 1, Daniel gets the goggles. Betty she gets exactly 3.31 grams of lead 2 nitrate and 50 milliliters of water, like that. Okay, so here's what it's going to look like. You're going to have this beaker that looks like water and another beaker that looks like water. And what you're going to do is you might have to stir them. Okay, can you stir them? And so you stir one of them so they'll dissolve. But aren't you trying to get 100% yield? So here's what you're going to like. Here's what you tend to do, like at home. You have this beaker, and you want to stir the stuff in there, right? And you have a stirring rod, a glass stirring rod, and you go do 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 do. And then what are you going to do with that rod? What are you going to do with that stirring rod? You're going to lay it on the table? If you lay it on the table, isn't some of the chemicals still on the stirring rod? So how are you going to prevent that? How are you going to prevent losing chemicals by putting the stirring rod on the table? All right, and so what you're going to do is, you remember a thing called wash bottles? Okay, squeeze, and they have distilled water in them. And so when you get done stirring, you put that stirring rod right there, and you squirt that stirring rod a little bit, okay? And so it kind of cleans the stirring rod off, didn't it? Then lay it on the table. Same thing with the other stirring rod, like that. So then you got these 2 solutions that look like water, and you're going to go like this. You're going to pour one into the other, and something's going to happen. It's going to be surprising to you, okay? And so something's going to happen, and now think about this. I just poured this into that one. I poured the little beaker into the big beaker, and something happens in this beaker. What are you going to do with this beaker? What are you going to do with this one? You think you got every bit of that chemical out? No. So what you do is you take the wash bottle again, you squirt it, and try to get anything that might have been in there. You get that? So you're trying to get 100% yield. All right, now what's going to happen is when you pour it in there, you're going to have a beaker that's going to have a liquid on the top and a whole, I'm only going to tell you what color it's going to be. This is going to be very colorful, and it's going to be a solid, and it's called a precipitate. A precipitate is an insoluble product. So one of the products is going to be this stuff here. Now what I want to know is, how much does that weigh? How many grams of precipitate did you get? Well, it's wet. So what are we going to do? How can we separate this from this? How can we separate the solid from the liquid? What do you think, Zach? Give me an idea. How can you separate, I got this liquid, it could be like sand in water. How would you separate sand in a beaker of water and sand?
I don't remember what it's called, but I can put it to, it's like metal kind of,
And that's okay if you don't know what it's called, but we actually, in the first semester, you had to draw one of these in one of the chapters, and it was called a filtration apparatus. So what I'm going to do is show you how that works. So I have one over here. So we got this precipitate, and it's in with this liquid, and we want to separate it. And so these poles are over there. See that? See where the globes are? Underneath the globes, there's a shelf, specially made shelf just for these. And so there are two kinds of bars back there. One that's tapered. Everybody know what the word tapered means? Coming to it. Okay. The tapered ones fit in here like that. That's like your ring stand, isn't it? This is your ring. And now I'm going to set up a filtration apparatus. So what you have oops, one more thing. Oh, I know. My advanced chemistry kids, they were using phone. See? So here we have a funnel, and this is called filter paper. Got that? Now what you have to do is, you have to fold it once, that makes a taco. Now you don't want to crease, it's not origami, don't crease it hard, crease it nice and soft a little bit, right? We don't poke a hole in this. You're gonna crease it again, but not hard, just like that. So I got myself a funnel here, and then you have to open up just one. Don't open from here, just open up one. I'm gonna stick that in here. I'm gonna see if I can have some bigger filter paper for you. This is kind of small. And then what you do is, the filter paper doesn't want to stay there, so you have to wet it. Oh, not full. I'll get these filled up for you, okay? So what I'm gonna do is, I want to get this thing wet. There we go. Okay, that's good. All right, there we go. Now I'll get some bigger filter paper so it's a little bit, fills up the funnel a little bit more. Now what you're gonna do is, you're gonna have this beaker that has this precipitate in it, and you wanna separate it, and so you're gonna have to go like this. You're gonna stir it, and pour a little bit of it in here, maybe about 3/4 of the way up. And then it's gonna gravity. Gravity's gonna let the liquid part fall through, and the solid part won't fall through. And so when you get done, that's what takes the most amount of time. So if you don't start on time, this is what takes a long time. You'll be here longer than you wanna be, okay? And so now, this thing is getting fuller and fuller. You gotta keep doing it, keep doing it. There'll be some on the beaker. You have to scrape it. Maybe squirt it a little bit and try to get all that precipitate off and get it in here. Now, what do you think we're gonna do there? It's kind of weird, but I'm gonna let this sit here. I could let it sit here. We really want it to air out a little bit. So what I'm gonna ask you to do is go to one of these paper towel dispensers, pull out 5 paper towels, and then fold them. That gives me 10 layers, right? That's 10 layers of paper towel. And then what you have to do is, you have to go in here and try to get this filter paper out of here without getting the precipitate on your finger, okay? I definitely am gonna get you bigger filter paper than this. So when you get done, you're gonna go like this, and you're gonna lay it on the paper towel. You're gonna try to unfold it. See that? And then it should be able to dry. It'll take about 2 or 3 days to dry, so we're gonna, if everybody gets to this far tomorrow, then you'll be in good shape. But I want you to put a great star on this lab. The very first, up at the top of the lab, and make it as big a star as you can. There's one thing, look at this right here. When this thing dries out, it'll have the precipitate on it, right? I want the mass of the precipitate, but what's hanging on to it? What's the precipitate hanging on to? It's hanging onto the paper. I don't want the mass of the paper, do I? Well, what is the mass of the paper? You don't know. So what is the absolute first thing you have to weigh? What's the first thing you have to weigh before you even do this lab? The dry filter paper. Put a little star there. Weigh the dry filter paper first. It's not on there, see, but the author thinks that you already know this, okay? So anyway, put a little star there, say, weigh the dry filter paper first. Because once it gets wet, you won't know how much it weighs. All right, you okay with this so far? You okay with this? All right, here's what I'd like you to do now. You're gonna sit with your partner, and what we're gonna do is, this is the entire lab write-up, right here, kid. You're gonna eventually fill out everything on this sheet, you're gonna fill it out. Take a look at the top. What is the mass of the lead 2 nitrate? Well, if you're good, it should be 3.31 grams, shouldn't it? Okay, it says here, what is the mass of the filter paper? You better make sure that you measure that first, right? Put that there. Anyway, so there's some of these things you have to wait until the lab's done to do, but some of them you can do like the balance equation, we'll do that also. All right, so let me tell you who your partners are, and you have the rest of the period to come up with a plan. And all I want to do is, you're just going to tell me step 1. Somebody's going to go weigh the filter paper. Somebody's going to get the goggles. Somebody's going to go weigh out 3.31 grams of lead 2 nitrate and put it in a 250 milliliter beaker. All right, so here's your lab partners. Now, I might have to redo this because I thought Madison would be here. Okay, good. One group of you only has 2 of you, and the rest have 3. And since Madison's not here, you still have 2, so you can do it. All right, group number 1, and Madison will be in your group, but she won't be able to do it today. Madison is group 1, and Isabella is group 1, and so is Kyle. That's group 1. So right now, Isabella and Kyle, you're going to get together. Then May is group 2, and Julia, you're group 2, and Zach, you are group 2. Group 3 is Aurora, and Aurora's with Daniel, and also with Sierra. That's group 3. And group 4 is, dang it, Delaney. Delaney and Layla. Okay, that won't work.
Layla can do it with us.
What now? What would you like to do?
Layla can do it with us versus
Well, Delaney has to do the lab, but what group was, I'll tell you what, since Madison's not here and Delaney's not here, I'll just let them be partners. I'll just let Madison and Delaney be partners, okay? All right, so everybody go ahead and get in your group, and all everyone should do is turn in a little piece of paper to me, and it says, what are you going to do? Read the lab over again and say, what do I see myself doing?